Hi kids, we will be going into this paper discussion. You can look at the first question. Three ants are sitting on the vertices of an equilateral triangle of side A at t equals to 0. Ant 1 starts approaching ant 2 with speed v, and ant 2 starts approaching ant 3 with speed v, and ant 3 starts approaching ant 1 with speed v. A is 1, v is 1. And there were a couple of options here. I think it is similar to your numerical question from your revision material, which was something like this. Yeah, so if I go by step, three ants meet at the centroid of the triangle. By symmetry, they will be meeting at the centroid of the triangle. This triangle is going to shrink and is going to rotate. So at any generalized moment, it is going to look like this. First one approaching second, second one approaching third, third one approaching first. Now they were asking after what time they are going to meet. So the easy way of doing it is seeing at what rate this length is shrinking. This length will always shrink at a rate of v plus v by 2. This component is v by 2 root 3v by 2. So this length will always be reducing at a rate 3v by 2. So when will this length become 0? It will become 0 after this much time, a by 3v by 2. Its initial length is a and it is reducing at a constant rate of 3v by 2. So after this much time, where a by v is 1. Now angular velocity, this question was, okay, so angular velocity is also easy to find. So what you will be doing is you will be sitting on one and you will be observing the other. Only perpendicular velocity matters. Perpendicular velocity will be root 3v by 2. So angular velocity will be root 3v by 2 by this distance. Now at any moment, similarly, if you want to calculate alpha, you need differentiation of omega. At any moment this perpendicular velocity is root 3v by 2. So when you sit on one and when you observe the other, you will be getting x into omega is root 3v by 2. This is constant, these two are varying. When x varies, then omega also varies. So if you differentiate it, you will be getting dx by dt. Dx by dt is the rate at which this length is changing. It is varying at a rate 3v by 2. We have already seen, and it is reducing. So minus 3v by 2. So UV rule, and they are asking initially. So when x is a. So from here we will be getting alpha. I think this is the question from your revision material. This is the exact question in your revision material. Now they were asking after time a by 4v. After time a by 4v, how much this length will reduce? It is reducing at a rate 3v by 2. So it is going to reduce by this much amount. If it reduces by this much amount, it is going to become this much. If it reduces by 3 by 8, it is going to become 5 by 8. Then area, if the side is 5 by 8, is root 3 by 4 times of this square. A man walking downhill with velocity v0 finds that his umbrella gives him maximum protection from the rain when he holds such that the stick is perpendicular to the hill surface. When the man turns back and climbs the hill with a velocity v0, he finds that it is most appropriate to hold the umbrella stick vertical. The actual speed of the rain drops in terms of v0. So when he is going downwards, he is holding the umbrella like this. The meaning is with respect to him, raindrops are hitting this way. So if I take this as my x-axis and y-axis thing, these are two mutually perpendicular axes. Rain will be having some random velocity, which I can always say will have horizontal, this component and this component. And with respect to man, rain is falling vertically, I mean this direction. The meaning is in this direction their velocity should be same. Only then with respect to man, rain will be having velocity in this direction. That's the first scenario. Now we understood rain has some random velocity which can be resolved into v0 in this direction, and this one we don't know, which I am calling it as y. So that is the actual velocity. Now when man is climbing up, with respect to man, when you observe from man's frame, rain will be having an extra velocity v0. Here with respect to man, this velocity will be getting cancelled. With respect to man, it will be having an extra velocity, and the resultant is falling vertically. So if this angle is 37, this is going to be 53. So this is going to be 53. So resultant of these two velocities should be in this direction. The meaning is tan 53 is y by 2v0. From there you will be getting the value of y. If you know the value of y and this value, then resultant is going to be root of this square plus this square. Consider the given system, neglect friction everywhere. The wedge C is movable. The system is released from rest. The velocity of the wedge C when B goes down the incline by 1 meter. So there are many things here. So just listen to what I say. So if the wedge is fixed, you should understand if A moves by distance x, then this pulley moves down by distance x, and this part will disappear, and this will go down by 2x. So if the speed is u at any moment with respect to wedge, then this speed will be 2u, or if this goes down by 1 meter, this will go up by half meter. Now you should understand, for this entire system there is no external force for 5 kg, 5 kg, 10 kg, that entire system there is no net external horizontal force, so momentum should be conserved in this direction, and velocity of the wedge will be only in the horizontal direction, which I am assuming this way. So if the velocity of the wedge is this way, then velocity of A or B, I can break it into two parts, velocity of the wedge and velocity with respect to wedge. Similarly, velocity of the wedge and velocity with respect to wedge. With respect to wedge, if this is going up with speed u, this is going to go down with speed 2u. So that's the scenario, how it looks in ground frame. And wedge constraint is already there, because with respect to wedge we said it is moving this way, that itself is wedge constraint. Now when you do momentum conservation in the horizontal direction, you will be getting this equation. I have simply wrote green momentum equals to yellow momentum component in the horizontal direction, or you can do individually. This momentum is negative, this momentum includes this plus this momentum includes this plus this. Net should be 0. When you do that, you will get this equation. When you modify it, you will be getting the relation between V and U. Now there are two unknowns, so we need two equations. The other equation is energy conservation. When this goes down, there is drop in potential energy. Drop in potential energy is mgh. If this goes down by 1 unit, this is going to be 1 sin 53. 1 sin 53. Drop in potential energy equal, and this guy has increment in potential energy, which is, if this goes down by 1 meter, this will go up by half meter. So its vertical component will be half sin 37. Half sin 37. So drop in potential energy of this guy, increment in potential energy of this guy, that is the net drop in potential energy, which will be going as increment in kinetic energy of all the three blocks. Increment in kinetic energy of this guy is this much. For this guy, it is going to be half into this mass into its total velocity square. So its total velocity square is Vx square plus Vy square. Vx, velocity along x axis, is V minus u's component, V minus u's component, Vx square, and u's component in this direction is Uy square. Similarly for this guy, in this direction velocity is this minus this, V minus 2u's component, that is velocity along x axis square plus velocity along y axis square. So that's the energy conservation equation. Now we need to find what is V. So we will be substituting u. U is 5v by 4. So we will be substituting for u. When you substitute for u, this equation is going to become equation with only v. Right. So we did momentum conservation and energy conservation. Wedge constraint was written there itself. In list 1, a situation is depicted, each of which is in vertical plane. The surfaces are frictionless. Match these with appropriate entries. So let me talk about the first case. So the first case was bead. So bead can never lose the track, and it is projected with this much speed. So initial kinetic energy is this much, potential energy is this much. If the particle suppose reaches here, then its potential energy will become 10 units mgh. If the particle reaches here, potential energy is 20 units, but kinetic energy is only 12.5 units. The meaning is it is going to cross this point and it is going to reach here. It is never going to leave the contact because it is a bead. Now when it comes to rest here, you should be able to see velocity is 0, so centripetal acceleration should be 0. So weight's component should be balanced by normal, and this component will be creating a tangential acceleration. So centripetal acceleration is 0, but tangential acceleration is there. So if I look at the options, normal force is 0. No, normal force is not 0 because it is balancing this mg's component. Velocity of the body is 0 at the topmost point. Yes. Acceleration of the body is 0. No, it has a tangential acceleration. And normal force is radially outwards. Yes, it is balancing mg's component. Similarly, going to the next part, kinetic energy is 10 units, potential energy is 0 units. Potential energy here, if it goes, it is 10 units. The meaning is kinetic energy will be fully converted into potential energy. So this is what is going to happen. In that case, normal force is 0 at the topmost point. Yes, because there is no force in this direction. Velocity is not there, so centripetal force is not there, so normal need not be there, but it has a tangential acceleration. Velocity of the body is 0 at the topmost point, yes. Acceleration is 0, no, it has g acceleration downwards, which is tangential. Normal force is radially outwards, normal force is 0, so then we'll go to this one later. That's little complicated over the remaining, so we can look into this. Again, if I take this as reference, kinetic energy is this much, potential energy is 0. If I take this as reference, potential energy here will be 10 by 3 units. Kinetic energy or total energy here is equals to potential energy here, so it can go till there. It can go till there, and in fact, it is going to stop there. So at the topmost point, normal is going to be 0. No, normal will be balancing mg. Velocity is 0 at the topmost point. Acceleration is 0 at the topmost point. Yes, there is no centripetal, there is no tangential. Normal force is radially outwards. Yes. Velocity is 0, acceleration is 0, normal is outwards. Now, going to this one. Again, if you take this as reference, potential energy is 0, kinetic energy is 18 units. So it is going to cross this point, but it can't cross this point. But from the given options, you should understand option D is the answer. The other way of saying it is, you have to convince only one is correct. Or once it crosses this and it can't cross this, obviously it is going to leave the track. So if you use energy conservation from here to here, potential energy here plus kinetic energy here, I am taking mass is 1 unit. Anyway, m will get cancelled, so I can take whatever I am comfortable with. So potential energy plus kinetic energy here should be equal to total energy. Apart from that, when it is losing contact, let me say it is losing contact here, so normal is going to become 0. So mg's component alone will be sufficient for centripetal. When you solve for these two equations, you will be getting sin theta. If you substitute it back, you will be getting v square. Anyway, sin theta is a feasible value we are getting, so v square also you will get a feasible value. The meaning is it is going to lose contact here. I mean, that also you don't have to do, you can understand it is going to lose contact. So if it loses contact, it is going to be parabolic path. If it is parabolic path, at the topmost point, velocity is not 0. Normal force is 0 at the topmost point, yes, because it is not touching. Velocity of the body is 0 at the topmost point, no, it is projectile motion. Acceleration is 0 at the topmost point, no, it is free fall, acceleration is g. Normal force is radially outwards, there is no point of talking about normal force radially outwards. Two particles are undergoing curvilinear motion in xy plane, their position vectors are given. Radius of curvature of particle 2 with respect to particle 1. Particle 2 with respect to particle 1. So, position vector of particle 2 with respect to particle 1 will be given by this much. These values were given in the question. So, this is the position vector of particle 2 with respect to 1. Then when you differentiate it, you will get velocity of particle 2 with respect to 1. When you differentiate it, you will get acceleration of particle 2 with respect to 1. And at t equals to 1, these values are going to become this much. Now the easy acceleration you can find is tangential. Tangential acceleration is acceleration's component in the velocity direction. Acceleration's component in the velocity direction. So this is tangential. Once you know tangential, you can find centripetal easily. Now if you want to find radius of curvature, obviously this is the first thing what you should be knowing. You know centripetal acceleration, you know velocity, so you can find the radius of curvature. In fact, if you want, you can find in vector forms also, but this is sufficient enough for the question. A car of mass 1200 kg started from rest and speeded up at an acceleration of 2 meters per second square along a straight horizontal path of 200 meters. Its wheels did not slide. The meaning is there is no slipping. So net work done by friction is going to be 0. In fact, work done by friction alone is going to be 0 because bottommost point is momentarily at rest. So work done by friction force is going to be 0. So option C is straight away wrong. So if you want to find what is the total friction force, now center of mass is moving because of friction, but work is done because of the engine. So mass is given, acceleration is given, so friction force you can find. Then increment in kinetic energy half mv square. V square you can get by using v square minus u square equals to 2as. Right, from here itself you can find what is the final velocity, which will be 72 root 2 units. That's a easy question. Understand, internal forces can't move the center of mass, so center of mass is moving because of friction, but friction is not the one which is doing work. Internal forces are the forces which are doing work. Okay, so I'll be reading the question while showing you the solution. So the question goes like, consider vernier caliper in which each 1 centimeter of the main scale is divided into 10 equal parts. The meaning is one main scale division is 1 mm and 7 vernier scale divisions were coinciding with 6 main scale divisions. So 1 vernier scale division is 6 by 7 main scale divisions, which is 6 by 7 mm. So vernier constant is going to be 1 MSD minus 1 VSD. Vernier constant here is going to be least count also, because it is n MSD is n plus 1 VSD. So in that scenario, vernier constant is going to be same as least count. So that will give you option A. Then in coming to screw gauge, they were telling 50 divisions were there, and when you rotate by 50 circular scale divisions, how much it moves, that is the gap between the two consecutive threads, which is pitch. So if you move by 1 circular scale division, it is going to move by pitch by 50 units. And they were saying if the pitch is 1 by 7, then 1 circular scale division, which is going to be least count of this instrument, is 1 by 350. So option B is correct. So if option B is correct, option C is wrong. And if the linear scale division, if the pitch is 1 mm, then 1 circular scale division, which is least count, is going to be 0.02 mm. So option D is also correct. So which of the following are correct? So this is from your NCERT experimental skills. So I'll be showing you the options where they were talking about, so you can look into it to understand better. First thing is, wire may not have an exactly circular cross section. You can see this diameter is D1, this diameter is D2. Therefore, it is necessary to measure the diameter of the wire in 2 positions. So in one position like this and in the other position like this, at right angles to each other. For this, first record the reading of the diameter D1, then record and then rotate by 90 degrees. And in fact, the wire may not be true cylindrical. Therefore, it is necessary to measure the diameter at several different places for average value. So you don't measure only at this location, you will be putting at some other locations also. And then you take the average so that you get less error. Then ratchet arrangement in the screw gauge must be utilized to avoid undue pressure on the wire. This may change diameter. So you have to move it. You have to move it using this so that it applies even pressure and which help us in reducing the error, or which doesn't change the diameter much. So move the screwdriver in one direction, else the screwdriver may develop play. We will see what is that later on. That play and backlash error all are similar things. Error due to backlash though can be minimized but cannot be completely eliminated. You can see what is backlash error here. In a good instrument, either screw gauge or spirometer, the thread of the screw and that of the nut in which screw moves should tightly fit with each other. However, with repeated use, the threads of both the screw and nut may get worn out. As a result, a gap develops between these two threads, which is called play. The play in the threads may introduce an error in measurement in devices like screw gauge. This error is called backlash error. In instruments having backlash error, the screw slips a small linear distance without rotation, as they were not tightly there. So if you just press it, it is going to move. So to prevent this or to reduce this, it is advised that the screw should be moved in only one direction while taking the measurements. And yeah, I think that should be sufficient enough to answer the question. While measuring the diameter of a given wire, screw gauge it is necessary to measure the diameter of the wire for 2 portions at right angles to each other and repeat the same at several different places of the wire and obtain the average value of the diameter. Yes, that's what we have seen now. Ratchet arrangement in screw gauge must be utilized to avoid undue pressure on the wire, as this may change the diameter. I think they picked up this question from exactly the same material because the statement looks same. In a screw gauge, the thread on the screw and that is this one also is from the same material, and you can see I think they want you to understand it can't be completely eliminated, it can only be reduced. The driving wheels of a steam locomotive are connected by a rack one link of which is flat horizontal rod. Okay, so and this distance is half of the radius. The rod remains horizontal, and while inspecting the locomotive, the mechanic placed a toolbox on this rod and absent-mindedly forgot it there. The locomotive starts, rod remains horizontal, and the locomotive starts moving and very slowly begins to pick up the speed. The meaning is it's not accelerating by a big amount, so you can say like it is accelerating by a small amount, so pseudo force is not necessarily needed to observe the phenomena from that frame, from the cart frame, from the locomotive frame. In locomotive frame, so this will be performing circular motion. So every point on this rod will be performing circular motion of radius small r, which is capital R by 2 given in the question. So at any moment when the situation is like this, there will be mg, normal and friction. As it is performing circular motion of radius capital R by 2, which is smaller, then there should be some centripetal force needed. So centripetal force needed is m omega square times of smaller. So its vertical component will be provided by net force in this direction, its horizontal component will be provided by net force in this direction. So friction will be providing centripetal's horizontal component, mg minus n will be providing centripetal's vertical component. Now you can see under the critical condition, when it is losing contact, normal should become 0. When normal becomes 0, you will be getting the omega value as a function of cos theta. Then you want to see the minimum value of omega. For that you will be checking maximum value of cos. So you will get omega minimum where normal is going to become 0. Omega where normal is going to become 0 if you put the equal to condition. So once you get omega, omega of this thing is same as omega of this wheel also. So if you want to talk about velocity of the locomotive, then that is going to be capital R times of omega, as it is pure rolling. So V should be equal to capital R times of omega. Capital R times of omega is going to be almost 4.47. In the similar manner, if you see, friction is providing this much, so maximum friction should be greater than or equals to this. So again, when you do the same way, you will be getting omega as a function of theta. But if you want to check what omega minimum it is going to happen, for that this has to be maximum. Its maximum value is root of 1 plus mu square. So you will get omega minimum value. When you multiply with capital R, you are going to get what is the velocity of the locomotive at that time, which is almost 3. So the meaning is, when the velocity of the locomotive is almost 3, there is a chance of slipping, and when the velocity is almost 4.5, there is a chance of losing the contact. So 3 is going to occur earlier than 5, 4.5. So it is going to slip first rather than losing the contact. So it is going to slip, option B, and box will start to slip relative to the rod when that speed is almost 3 units. A non-uniform rope of length L is placed on the ground and rope is pulled by a constant force as shown in the diagram. There is no friction anywhere. Linear mass density is varying with the distance where x is measured from here. Choose the correct options, and all are straightforward questions. So if you want to find the mass, you will be taking some element at a distance x, then its mass will be given by linear mass density there times of that length. When you integrate this from 0 to L, you will get the total mass. Then if you write F equals to m into A, you will be getting the acceleration. Then if you want to find the tension anywhere, then you will draw the free body diagram of this. Then you will set tension there should be equals to mass there time mass till this much mass into acceleration. How to calculate this much mass? While integrating, you integrate from 0 to x, then you will get this much mass. And acceleration we already calculated from here. When you substitute, you will get tension as a function of x. Then they were asking you to integrate this to evaluate option A. So integrate this one to get option A. Time varying forces act on the bodies as shown in the figure. This force is 40, this force is T. So if you take this as your system, either they have to move together or they have to move separately. but if they have to move together, you should understand net force is 3T in this direction, so they tend to move this way. Meanwhile, frictions will be coming into picture. And maximum value of friction here is going to be 100, here is going to be 150, that you can calculate by yourself. Then they were asking the relative motion between A and B will start. So if there is relative motion between A and B, the meaning is this friction is going to become maximum. So if I draw the free body diagram of this, then it is going to be 40 minus 100 minus 150 equals to 10 into A. Similarly, if I draw the free body diagram of this, there is force 100, so 100 minus T equals to 20 into A. Till then they were moving the same acceleration, so same A. So two equations, two unknowns. When you solve for that, you will get A is 5 by 3 and T is 200 by 3. So till time is 200 by 3, they will be moving together. At 200 by 3, they will be still moving together with an acceleration 5 by 3 and common velocity also. Now that's the thing. So rest two of the options, time is more than 200 by 3. The meaning is they were moving separately. So even if they are moving separately, if you want to find acceleration of center of mass, net external force on the system. Net external force on the system is 40 minus T minus 150. This is internal force. Net external force on the system equals to total mass times of acceleration of center of mass. You will get acceleration of center of mass is 5. In fact, direction is this way. Similarly, magnitude of relative acceleration. So you write F equals to ma, F equals to ma. But the difference is these two accelerations are not same anymore. So if you write the first equation, you will get acceleration of 10 kg block. If you write the second equation, you will get acceleration of 20 kg block. Both are moving in this direction. Relative acceleration is 6 units. Two resistors R1 and R2 have measured values like this, and least count of the device used to measure R2 is 0.2. Generally, that is how we are going to say whatever is written here, it's the least count of the instrument, that is the maximum possible error when connected in series and when connected in parallel. So when connected in series, you can calculate equivalent resistances. If this value is 3 and this value is 6, then the equivalent resistance is 9. But this value is not exactly 3, this value is not exactly 6. There is a variation. So there is a variation in this also. How much variation maximum possible? That is going to be given by delta R1 plus delta R2, which is 0.3. So if you want to take the percentage error, it is going to be 3.33. They have given 3.34. Oh, so ideally it should be 3.33. So similarly, when connected in parallel, equivalent resistance will be 2 units. And significant figures will be deciding based on the maximum error. So if I want to calculate the error, I will be differentiating this, and I know R value, R1 value, R2 value. If I substitute delta R1 also I know, delta R2 also I know. When you substitute, you will be getting this much, you will be getting this much, but you will be rounding it off to one significant figure. Rather than this, we will be rounding off to this. That's the better option, because we can see there is an error in first decimal. So if there is an error in the first decimal, equivalent resistance can't be this much accurate. Now once the error is having, so once we say there is an error in this location, yeah, we can say like whatever our answer is 2.0 plus or minus 0.1. Two small balls, each of mass m, are placed on smooth horizontal surface connected by a light string of length 2L as shown in the figure. The midpoint of the string is pulled vertically along the y direction by applying a constant force F. These particles are sliding over the horizontal table and start approaching each other. They do not lose contact on the table before collision. Then the relative speed of two particles when they are about to collide. Relative speed of two particles when they are about to collide, and the two particles collide and stick to each other, then the loss in kinetic energy. So only two options can be correct maximum here. So you can see when you pull it, it is going to go like this, and yeah, eventually they are going to hit. When they were hitting, their horizontal velocity should be same in magnitude, vertical velocity should be same by symmetry. So if they are talking about relative velocity is going to be only in the horizontal direction, that is 2 times of Vx. Now at any moment, if you look at this point free body diagram, there is F, there is T, there is T. So this net force on this massless point should be 0. So F should be equals to 2T cos theta, and T sin theta will get cancelled. Now So force here is going to be T cos theta and T sin theta, T cos theta and T sin theta. We already understood T cos theta is nothing but F by 2. So eventually what happens is when this point goes ahead, these two are going to come closer. So work done by this force. So let me say these masses have traveled by distance d, and okay, so the masses were here. So when they were hitting, let me say the masses were here, they travel a distance d. So this point would have traveled a distance d plus L. So work done by this force is going to be F into d plus L. Work done by this force is going to be F into d plus L. That should be equals to change in kinetic energy of both, because that's the only way the energy can be gone. Work done should be equals to change in kinetic energy. Change in kinetic energy is change in kinetic energy of this guy plus change in kinetic energy of this guy. Now you should be able to understand half into m into Vy square. Half into m into Vy square. I can see it as there is a constant. So let me say this particle is somewhere here, and there is constantly F by 2 acting. Constantly F by 2 acting till a distance d. Then change in kinetic energy of that guy is going to be F by 2 into d. So I can simply write half m into Vy square as F by 2 into d for easy calculation. So from there you can see F by 2 into d, 2 is also there. So F into d d will be getting cancelled. So from here we will be getting velocity along x-axis. So 2 times Vx is going to be relative velocity, and whatever kinetic energy existing now, that's because of the velocity in the horizontal direction, that is going to disappear. So this much amount of energy is going to disappear. So loss in kinetic energy is going to be F into L. And there is an explanation also in both ways. You can look into it if you want. A particle was moving along the x-axis with speed u less than 4. At t equals to 0, variable force starts acting on the particle so that its acceleration along x-axis and y-axis change periodically. You can see along x-axis it was 0 for first tau, then it is a for next tau, then it is 0, then it is a by 2, then it is 0, then it is a by 4, then it is 0, then it is a by 8, and so on. Similarly here a 0, a by 2 0, a by 4 0, a by 8 0, and so on. In the subsequent motion, the maximum angle between the particle's velocity and its initial velocity is along x-axis and speed is less than 4 units. And the maximum angle between the particle's velocity and initial velocity is 53 units, and a into tau is given 2 units. Find 10 times of maximum speed achieved by the particle. Now, this is the initial velocity along x-axis, whose value we don't know, we are going to figure it out. Then if I talk about first tau units, because of that there will be increment in velocity only in the vertical direction, which is a into tau, area under the graph. A into tau is 2 units. So velocity along y-axis will increase by 2 units if I talk about and time interval tau. If I talk about next time interval tau, then velocity along x-axis will increase by 2 units. In the next time interval, velocity along y-axis will increase by 1 unit, because this is a by 2. A by 2 into tau is 1 unit. Similarly here 1 unit. So that keeps going. Now you should understand, initially resultant velocity is this way, after tau units resultant velocity is this way, after 2 tau units resultant velocity is this way, after 3 tau units resultant velocity is this way, 4 tau resultant velocity is this way. So resultant velocity is making maximum angle with the initial velocity after time tau, and they said this angle is 53 degrees. So tan 53 when you use, you will get this velocity is 3 by 2. Now velocity along y-axis or velocity along x-axis, if you want to find, you need to find the area under the graph. So that was 2 plus 1 plus 1 by 2 plus 1 by 4 and so on. That will give you what is the increment in velocity along y-axis, which is going to be 4 units. Similarly, increment in velocity along x-axis is also going to be 4 units. So net velocity along y-axis is going to be 4 units. Net velocity along x-axis is going to be 3 by 2 plus 4 units. 3 by 2 plus 4 units. Then you can find the resultant velocity. And in case if you want to find root 185, I think there should be many other ways. One way is like you can understand it is between 13 and 14. Root 185 is between 13 and 14. This is the actual value for your reference. So some people will write it as 196 minus 11 and they will be using binomial approximation. Some people will write as 169 plus 16 and they will be using binomial approximation. Now you should understand, this is approximately 0.06 and 0.09, so this error will be less than this. You should be understanding this value is closer to this than this. So understanding this fact, probably I can write 185 like this, so that I can use the binomial approximation, and you can see here it is 0.04, which is less than these two. So the error in this answer is going to be even less than the error in these two. So this is more closer than these two answers. So there are many ways of doing it. I think you have a straightforward way of calculating also, so that is up to you. A horizontal electrical wire is stretched at a height 10 meter above the ground. A boy standing on the ground can throw a stone at speed 20 units. The maximum horizontal distance x at which bird sitting on the wire can be hit by the stone is. Now if he throws exactly vertically, it can cross this and it can come. In fact, you can calculate maximum height. Maximum height is more than 10. I think it is going to be 20. So when he throws some other angle, it is going to go like this. When he throws at some other angle, it is going to go like this. So there are lot many possibilities. So let us see. They said fixed h. So let us write the projectile first. So there can be many possibilities where it can hit. So you can throw projectile, and I think this is going to be maximum range thing also, which is not really important for us, because you can see here, even if the crow is beside this maximum range projectile, still we can hit the crow if you are throwing at this angle. So this is not specifically important for us. Anyway, if you write the projectile equation, h is fixed. So along y axis, y equals to ut. 20 is the speed. So if I take angle is theta, 20 sin theta into t minus half gt square. X coordinate will be given by this much. Now you need to eliminate the time factor. So t is x by 20 cos theta. When you substitute it, you will getting whatever equation that is called as equation of trajectory. Now you can find it is quadratic in x. So you can find x as a function of theta, and you can see what is the maximum value of x. That is one way of doing it. Or there is other way of doing it. You can see it as quadratic in tan theta, Once you see quadratic in tan theta, and for real values of tan, b square minus 4ac should be greater than or equals to 0. When you do that, you will be getting x square should be less than or equals to 80, or x magnitude wise should be less than 20 root 2. So the maximum value of x for which y is going to be 10 units. The maximum value of x for which y is going to be 10 units is 20 root 2. So the meaning is, if the crow is in any distance which is 20 root 2 from here, he can hit the crow. If the crow is here, he will be throwing like this. If the crow is somewhere here, he will be throwing like this. If the crow is here, he will be throwing something like this. But there is a limit, he can't hit it anywhere. So the maximum he can hit is when the crow is maximum at a distance of 20 root 2. And yeah, so I didn't attach something here, so it is called a safety parabola. Probably I will be attaching the safety parabola, which goes by the similar manner. A power transmission line is laid in mountains. The weight of the wire between the supports is 192 units and its length is 12 meter. Its vertical distance between the highest and lowest point is equals to 5 meter. The length of the section AB is equals to 10 meters. Find the maximum tension force in the wire. Now we have already seen this question in our, I think, January 2nd advanced paper. So if you draw the free body diagram of any part, you should understand like horizontal tension will be same. So horizontal tension will be same everywhere and vertical tension will be maximum here. So net tension maximum is going to be here. So they are asking you to calculate what is the tension at A. So it was similar to this question from your January 2nd exam. There you would have understood difference in the tensions, difference in the actual tensions. Difference in the actual tensions of two locations depends only on the vertical distance. So if I borrow that result here, difference in the actual tensions will depend only on the vertical distance. Now similarly here, net tension is going to be this square plus this square. This tension square equals to this tension square plus this tension square, and horizontally tension should be same. Now you need to calculate what is tau. So for that I will be taking this equation and I can write this as a plus b into a minus b, and I can plug in this value here so that I will be getting what is a plus b value. Now once I know a plus b, a minus b, I can add them to get what is the actual tension here. It's only about solving equation. The main thing is understanding this. This I borrowed from that advanced paper. So once you get that, you can get tau value, then you can multiply and divide with total length, so that you can write this as 192 units given in the question. All the values were given in the question, you just need to substitute, but the key point for the question is this equation. You understand this equation was explained in that particular paper discussion. Massless pulley P is moving vertically downwards with constant speed 15 units. Find the velocity with which the block Q moves up at the instant shown. So if the pulley is moving downwards with 15, this point on the pulley is going to go down with 15 units. So its component along the string, or that point on the string is also going to go this way with 15 units. So its component along the string is going to be 15 cos 53. This angle is 53 units. This angle is 37. So this angle is going to be 53 units. So 15 cos 53 is 15 into 3 by 5, so that is going to be 9 units. So this length is going to increase by 9 units. Similarly, this length is also going to increase by 9 units. If this length is increasing by 9 units and this length is increasing by 9 units, this one should be reducing by 18 units. Or you can take this right angle triangle and you can differentiate it, that's up to you. The picture shown below, a picture of vernier screw gauge. The main scale or the pitch is 0.5 mm. There are 50 divisions on the circular scale, and 9 circular scale divisions correspond to 10 vernier. What is the reading? They were asking. So one thing is, they said it is 50 circular scale divisions and gap between these two is 0.5 mm. We are going to take that as pitch itself. So one circular scale division or least count of this, okay, I can say only circular scale division. I can't say the least count because we have vernier scale, so least count is going to be different thing here. So one circular scale division, if I move by one circular scale division, it is going to proceed ahead by 0.01 mm. And they said 9 circular scale divisions are coinciding with 10 vernier scale divisions. So one vernier scale division is 0.9 circular scale divisions, I can say. Now keeping that aside, if you want to read this, it is going to be 0.5, 1.5. So similarly 5.5 mm till here. Now apart from that, it went down by 28 and something. Now 28 circular scale divisions and something. Now how to find that something? You can look at the coinciding thing. So these are 2 circular scale divisions, these are 2 vernier scale divisions. 2 vernier scale divisions is 1.8 circular scale divisions. So this is 2 circular scale divisions, this is 1.8 circular scale divisions. So this gap is going to be 0.2 circular scale divisions. So totally it is 28 plus 0.2 circular scale division, 28.2 circular scale divisions. 5.5 mm and 28.2 circular scale divisions. One circular scale division is equivalent to 0.01 mm. So when you substitute the value of CSD, then you will be getting the required answer, and you need to mark 10 times of that. Find the work done in this closed path by this kind of force. So that's a very straightforward question. So small work done is going to be F bar dot dr bar, that is going to be this much, and you have to integrate it. So now you should understand, in this whole path y coordinate is 0 and change in y coordinate is also 0. So total work done is going to be 0. In this path x coordinate is 0 and change in x coordinate is also 0. So work done is going to be 0. In this path, this equation is y is minus x plus 1. So I can say, if I differentiate it, dy is minus dx. So wherever dy is there, I can put minus dx. Wherever dx is there, I can put minus dy, so that integration becomes easy. While going from here to here, y value is varying from 0 to 1, x value is varying from 1 to 0. That will give you minus 1 as the answer. Going to the next question, a particle of mass m is there and there is It is conservative force and potential energy is given where A value and B value are 1 unit given. Total mechanical energy is 0, then the maximum speed. So you can plot the graph, or you can easily see how to plot the graph. This is a even function, so whatever happens on the right hand side should be same as left hand side, and you can see it is going to become 0 at 0 as well as minus root 5 and plus root 5, and it is going to be maxima or minima here, right? So similarly you can see what will be the values, and you can easily understand that is going to be, anyway you can easily understand the curve, or it is going to be minima at half of this root 5 by 2, or you can differentiate it and you can make it equals to 0 to understand where is it going to be minima. I didn't do that. Probably you can do that. U dash equals to 0, when you do, you will be getting root 5 by 2 or minus root 5 by 2. When you substitute this root 5 by 2 value, you will be getting the potential energy. So as this is minimum potential energy, kinetic energy is maximum here, total energy, potential energy here plus kinetic energy here is 0. From there you will be getting the velocity, right? So U dash equals to 0 you need to do, and you need to substitute the value, right? Thank you.